Hello, Doug Littrell again. It's July 18th. This is video number 35. I'm going to show some t-shirts that I offer. Sometimes I give them away free as a promo when I do a festival. I'm a member of FestivalNet, and so I can see upcoming shows, like craft shows, festivals, stuff like that. And so I can promote my stuff to the public there. Uh, got my book, of course, now, just published recently. We're going to offer those now. Some of the t-shirts I've got that I've had these made in 2015. At that time, was before I did the recent book, where I've compiled a lot of stuff. In 2015, I had 4 sheets that I was promoting. I was doing those for free as a promo, and I'm still doing them free as a promo. There's 3 on orbits, 1 on barycenter and sun wobble, and about Mercury's orbit and why Mercury's orbit precesses by some 1.56 degrees every 100 years due to sun wobble. The sun juts out a little bit, like half its diameter or so, and that pulls Mercury over a little bit. End of story. It's not hard to figure out. It's not arcane. We don't need any arcane equations for that. Some of the t-shirts I had made, I had a little boy's shirt made, faulty interpretations in science reinforce religion. So that's one of them. Another one just like it is the girls one, little girls one. I've got this one. I've got several more, but I'm just going to show a few of these. People kind of liked them at Rockfest. Sold some and gave some away. $10. Things without mass don't exist. Science thinks things without mass do exist right now, but I don't believe that's right. There are only 3 dimensions. I don't consider time to be a dimension. I think time or dimensions should be strictly the 3 dimensions X, Y, and Z. That's why I look at it. I don't like a lot of phony baloney garbage stuff that we don't need. Stuff that it just reinforces religion. All that kind of stuff. The more exotic you make it, with negative charge, and then it gets too complicated. And pretty soon it's like religion, because you need someone doing it because it's so unbelievably complicated. It's not like that. The universe and nature, it's all very natural. Very natural. Everything has a logical reason why it happens the way it does. I want to talk about my universe model today mainly. Here's my book again. It's Existence Uniformity. It's kind of hard to read it. It's got the moon iapetus on the front. All of the section division pages have moons on them, different moons. You can't hardly see this. Let's see. But this is, the second line says, Genesis, Jesus, conundrum, extrication. And this has a historical Jesus scenario in it. It's the most likely one anyone could come up with, if you understand what he was thinking, what he was doing, what he was about. Down here, a couple lines says, how could any attempt at science come without truth-seeking? So, that's one of my contentions, is I don't want to do just applications that we can use and make money off of. I want to understand what's going on as well. I want to do a better job at that. This last line is, deception isn't the answer to humanity's behavioral problems. Right now, if you accept religious explanations and intimidation of people through belief in hell and demons and all that kind of stuff, you are actually agreeing with clergymen who know better. There's a few who know better. Most of them think it's real, I guess. But there's a few who think that that system that they're using is the best way to make humans, intimidate humans so they stay in line and they behave. I don't believe that at all. You know, I know humans are disorderly, a lot of us, you know, and we're growing up and we're young, and you can continue that on into the adulthood, but, you know, you might need something that kind of, you know, is somewhat coercive, perhaps, at times. We've got laws for that. We have punishments, we have penalties for breaking the law and causing disorder. That's enough. We don't need fiction. We don't need religious fiction to accomplish that. We don't need people to be baited by belief in immortality. You know, like they're hooked because they hope they can live forever somehow, and so they're just going to, um, you know, play along with it and just hope that somehow they end up in an eternal place where they can live forever and be happy in eternal bliss, and it's all false. You know, it doesn't happen. Look, we evolved from the same thing that bacteria came from. Bacteria they don't have a soul, they don't have a spirit. Cats and dogs don't have a soul, they don't have a spirit. We don't have a soul. We came from, we have ape-like ancestors. We have, you know, we came from the same thing that hippos came from. Hippos uh, evolved in, a lot of them, some of them evolved into whales. Uh, you know, we're all of biology is related, and we came from that. And nobody evolved a soul or a spirit all of a sudden. That's phony. That's not true. We don't need that to be good people to get along. This is my universe model. I drew this in 2016, actually a year ago. This is July 18th. It's about a year ago I was drawing this. You know, I was getting ready to put this book together, and I was putting together some last minute things that would be an improvement on what I had done before, and that was one of them. Now I did that. I know you can't see it very well, but right after I did that, in August of 2016, I did this. And this explains how protons and neutrons form. And it also explains why galaxies spread. And this is a large collection. The matter comes out. Perhaps most of it falls back due to the massive gravity. Some of it is pushed out far enough to escape and keep going. And that's what makes galaxies. The part that escapes, those are the different level charges of photons. The white is the highest charge, and then the pink and the red, and those make all the different particles that are in atoms, and you know, even infrared particles, which are not in atoms but collide into atoms and particles in atoms. But anyway, the reason I'll mention this again, I think I touched on this in another video, but when these white and pink photons come out, they're the deepest buried in this collection. When they spew out into space, when it gains enough compression because of it gaining enough mass as this material returns to it, everything returns to it. Galaxies and everything in the galaxies, they get consumed in this black hole, and then as it gets more mass, it creates more compression on the photons inside it. They become more cube-shaped. They take on more positive charge. The ones buried deeper, more charge. The ones not as deep, very little charge, you know, to middle charge. The ones on the surface, they don't get distorted at all. They remain uncharged. Although the ones that return, a lot of them are charged, and then if, you know, some of those came off the surface when it spewed, which isn't very often, you know, they would come out and there would be charged particles from the surface as well. But once they get buried deep enough, they get uncharged. They get uncharged by the massive gravity of the thing pulling on all sides, pulling them apart, pulling them back out to be perfect spheres. But then once they get buried enough, again, now they are enduring a lot of compression and they become cube shaped again. And the cube shape they resist because their natural shape are spheres. But anyway, that's basically how it works. When they come out, the ones that come out, it takes a long time for them to even reach the surface of this enormous body. And so the whites are the fewest in the universe because, you know, it might take 1 billion or 2 billion years just to, at light speed, to reach the surface of this thing and get out of it. And those ones that are very deepest have the farthest to travel to get out into space. And so this thing is sitting there spewing for a long, long time when it spews. I don't know, 1 billion years, maybe more, maybe 2 billion years. But if you allow that these things can move at light speed, then you can figure out, and you figure out how big the thing is, then you can figure out how long it would take for them to reach the surface if they were in the center or close to the center. And that's the sort of thing going on here. When they get out, the whites repel each other tremendously, and so that already they're spreading apart by that. The pinks an awful lot as well, not as much, and pinks to white as well. So this stuff is spreading out, and that essentially is what's responsible for the galaxy spreading. It's already spreading, but even more so, the blacks, which are the surface photons that are uncharged, you know, down to a certain layer, they follow those. They're highly attracted to those whites and pinks. They make protons and neutrons because they're trying to attach to them because they follow them. And when they follow them, they're so highly attracted that they collide into them and can't attach, and so they knock them even further off of into a odd sideways trajectory. So, and eventually they catch up to them and can attach, and then these other attractive particles are following behind them, and they're making all these different particles. But that's how protons and neutrons are made. This is why galaxies spread. These things are moving apart. And so when I did the model and drew the model in 2016, it was right before that realization, August of 2016. I hadn't realized yet this is pretty straightforward as far as them coming out in a pattern, spreading out. The galaxies, they make galaxies. They make protons, neutrons, electrons, all these radio particles and everything, and then they make atoms, and they make stars, and they make, you've got black holes forming. And these galaxies are organizing, but they get so far away they turn like a comet does relative to the sun, and they're spreading, and then they come back. Now this is pretty organized. They keep spreading until they get to a certain point. Then they have to start coming together, and then they return to the collection. And this is this is symmetrical. You have all of these galaxies and groups of galaxies on one side of it. You have the mirror of it on the opposite side. It spews out, and these things spew out in two directions from two ports on opposite sides of this collection. Anyway, what I didn't realize when I drew this, what I just showed you on the next page, 2 pages, when you consider that, you don't have this straight line. I don't know if you can see that or not, but there's this from this collection. There's a straight line coming out. It's not that straight, as it turns out, with protons and neutrons forming, and all of those uncharged particles and low-charged particles falling behind them, colliding into them, and they finally reach the same velocity, and so they can eventually attach. But this is knocking them sideways. So we've got stuff going off in all sorts of trajectories, is the way it really is. This is a nice, neat thing here. But what actually happens is that stuff spreads out much more from the start. And then it goes out, and everything's got its own trajectory. It reaches a certain distance away with its momentum. and then it begins to circle back by gravity to the collection. So it's not going to be this well organized. But this is a good way to envision the principles of it, of the gravity turning it around and heading it back. Here's another drawing of the that I did in 2014 of the thing. Here's the first one I did, which is a pencil drawing. It's shown on here. Or that's one of the first ones I did. The first one I did is in my book, Endless Cycle Universe, and it's more primitive than this one. Here's a 3D drawing of it. You know, it wouldn't be two-dimensional, it'd be three-dimensional. So you have to envision that. And this one's about microwave background radiation coming around and returning in this type of a model. Now in that one, you can see that it's both sides of the collection are shown, and then you have this. You have some of these particles that go out way past where the galaxies are, and they're going light speed, and the gravity actually turns them. You know, we know that gravity can turn because of gravitational lensing. We know that gravity can turn photons a little bit when they go by the sun. So you're going to have, if there's a massive gravity source in the universe that's collected just due to gravity itself, then even particles like that, radio particles such as that that are involved in microwave background radiation, they will be affected by gravity eventually, and they'll come back, and they'll probably retain their original velocity as they're turning and coming back. So, and then they'll eventually collide into things like on Earth, and that's the way I explain that with this system. I want to mention this drawing. When you have the galaxies spreading, like I mentioned, okay, now I drew the Milky Way is located in the second, let's see, it's right here. It's in the second group. See these, you have basically halos, 3D halos that are spreading galaxies. It's worse than that because of the way protons and neutrons form, and everything else. But so it's a lot less organized than this. But this still helps you understand what's going on, because you have this model shows there being, see, this is one group, it's a halo. This is 2D, so it's in 3D that would be a halo here, and it hasn't spread that much, but it's turning to go back. The Milky Way would be in the second halo. It's turning to go back. And then these are spreading even more. This is the third. Now this is the first, the second, the third, the fourth. And then there's one over here, I think. There's probably about 5 out there. And there's like 39 billion years, let's just say 39 billion years, something like that, in between these spews in the space. So this is why galaxies are moving. You know, this would be why galaxies are moving. The reason they think it's a Big Bang explosion that caused everything, and that everything is moving out from a tiny speck instead of like this, from a collection and returning to a collection, is because when you're of redshift, the galaxies that are farther away are moving faster away. This was realized with Edwin Hubble was looking through telescopes, and he noticed that the galaxies, some of the galaxies were much more redshifted than others. And so basically all of them are redshifted except for Andromeda. Andromeda is moving toward us, but 99.99% are moving away, something like that, are moving away from us. And those that are farther away, it was noted, are moving faster away. Now, I don't know if we can, from the Milky Way, if we can see galaxies that are way over here, let's say, on the other side of that halo. Perhaps we can. You know, you just have to have enough time for the light to reach us, and it has to not be bent by the gravity of the collection so that it doesn't reach us. But if we were in this, say, in this halo of galaxies, then like I said, it's going to be much less organized than that because of the way protons and neutrons form. But let's just say we were in this second most recent spew of these particles that make galaxies. Okay, there's one behind us. Now, when we look behind us, we've already been speeding up, coming back, because when things are falling, they accelerate. And we're falling back to that collection. And we're making a rounded course, of course, heading toward it. We're not heading directly toward it, but we're kind of like in orbit. But this thing is so strong with gravity that we're not going to orbit it. When it gets back there, we're going to be, everything that in the Milky Way is going to be, with everything, other galaxies, is going to be consumed by it. You can't escape it. It's not going to just orbit it. It's going to go right into it. It'll try to circle it a little bit, but it's going to just, the gravity's too strong. But anyway, as far as the red shift of galaxies indicating that we came out of a Big Bang explosion, which is what's thought right now is most popular. If the Milky Way is located, say, right there, the galaxies that are close to us in the same group that we came out with, those out here will be moving slightly away from us because stuff is spreading out. Those behind us, we're going faster than those behind us. So those are going to be red shifted, not tremendously, but a good bit as well. Now, when you look across to these are spreading the opposite direction. They're going to be highly red shifted right over here. Look at that. Look at the direction. You would think in a model like this that everything that's the most red shifted is going to be back toward the collection. That's not the way it is. These across here are spreading away from us very fast. And these are going to be very high. There's going to be a lot of red shift. When we look across, we're moving out still, and they're moving the opposite direction. And they're also heading back. They're going to be very red shifted. These are going to be very red shifted. These are speeding up, heading back. These are going to be very red shifted when we look at these. These are going to be very red shifted if we can see these, which we probably can. These are speeding, all of these on this side are going to be speeding up because they have had more time to accelerate. All of these are going to be very, very much red shifted. And these will, so in any direction you look, they're going to be you're going to have some that are farther away. They're going to be very red shifted. Now, if you look, say, off in this, but when you have protons and neutrons forming, it makes it things even less organized, like I described. Now you have the possibility that some have a trajectory, and they're out here in this direction somehow, and some of those are liable to be redshifted. Basically, when you look more in this one direction here, okay, you're going to see fewer. There is going to be one specific direction. But look, all the other directions around you, you've got highly redshifted. There's going to be some that are highly redshifted. But there should be like one direction away from the Milky Way. You know, I don't know if you did a certain patch in the sky where they're not going to be as, you're going to have some that are not going to be as redshifted. There should be one direction you're not going to have the highest red-shifted galaxies. Although this accounts for all of those other I would say something on the order of 85% of the directions surrounding us are going to have there's going to be some galaxies that are going to, for some certain reasons, are going to have, with this model, are going to have very much red shift when we look